WhatsApp message
Yes,
is
sir,
here,
yes, sir. Yes,
isn't
sir.
it? Unnecessarily, you should not give trouble to the teachers.
Yes,
But
sir.
anyway, Sasank Harshvardhan is not attending. I don't know what happens to him. Some maybe he has some medical problems. I told you the quiz already I have given in the WhatsApp. It is you from your side also suggestion is here. It will be Friday. It's okay. Friday. Friday it's already I have conveyed to this section B. Probably. Harshvardhan, maybe he has taken the consent from section B. Unmute yourself. Sasank, you unmute.
Yes, sir.
Listen
Yes,
and
sir.
talk to me.
Yes,
Don't
sir.
unmute it. Why don't I talking to you when you unmute it? When I'm talking to you, you should unmute it.
Yes, sir. Yes, Lucas.
Just you'll be in the just you join it and next time you'll be sleeping. It seems to me.
Yes, sir.
So you take the responsibility. So what will be the time? He has not mentioned the timing. What is the timing? You just discuss it yourself and tell me after I asked Harshvardhan also
Yes,
to
sir.
keep the time after 5:30 when the classes are over. So after 5:30, what will be the suitable time? Friday. Friday means it is 8th.
Friday, yes, 8th April. Yes, sir.
8th April. 8th
Yes.
April. So what time will be comfortable for you? You tell me. Or
Yes, sir.
just after the class also you can mention it.
Okay, okay. Yes, sir. Okay,
After
sir.
the class, you'll mention it right now.
Yes, sir. After the class, I will mention in the group, sir. WhatsApp group or in the
Okay.
group.
Immediately you tell me because I have to convey these things to section B
Yes, sir.
also,
We also.
Soma madam, isn't
Yes,
it?
sir. Yes, sir. Yes, sir.
So because she will declare it also. So
Okay.
just now you tell it. And also one more thing, since next week I'll be out of stations.
Yes, sir.
So again 10 to 11 Friday 10 to 11 extra class will be there apart from the regular class.
Yes. On
Okay.
on Monday, sir.
It's,
On Friday
no,
only.
no,
This Friday only.
Friday only, Friday only.
Okay.
Because
Okay.
next week I'll be out of station, so 2 classes I'll be missing. Again, and after that week, immediately fifth quiz will be there.
Yes, sir.
Right. But Friday also you must inform the date for fifth quiz.
Yes,
Right.
sir.
10 to 11 extra class will be there, and 5:12 to 1. Uh, that is a extra regular class. So keep in mind. Okay.
Yes, sir. Yes, sir.
Okay. These things to keep in mind, and after this class, immediately you just give me the
Yes, sir.
time for
Yes, sir.
Friday 8th for quiz 4.
Yes,
Okay,
sir.
keep
10 to
note
12
this
this
all this
Friday,
point.
na, sir.
Yes.
10 to 12 this Friday.
Uh, no, 10 to
10
11
to
extra
11
class will
and
be there.
12 to 1. Yes, sir. Regular class.
12 to 1. 12 to 1 the regular class as it is.
Yes, sir.
Only
Yes,
10 to 11 extra class will be there because
yes, sir.
next week both Wednesday and Tuesday, the 2 classes I'll be missing.
Okay, sir.
Right. I'll be on leave. So that's
Okay.
why I'm just telling you. I know Friday is holiday, Friday, Good Friday. So
Yes.
these things, so only 1 week will be left. So before that, 50% of the syllabus should be covered, and the rest will be covered in the last week. Because
Okay.
22nd April is your last day for your
Yes.
this semester, right?
Yes,
I
sir.
think I have conveyed everything. Is it clear now? If you have any
Yes, sir. Yes.
questions, you can tell me.
Okay, okay. Yes,
So
sir. Yes,
everything
sir.
is clear now. If
Yes, sir.
anyone, those who are listening, I know how many persons. Let me check. Only 16 persons. Well, anyway, apart from Sasank, any other you can comment on the things just now I mentioned. Any other? If you have any objections or anything you want to convey,
No,
Ronak,
no, sir.
Bishop, Sahil, or you agree with this? Okay.
Hello, sir. Can I mute myself now?
Yes. What's your name? Utkarsh. Yes.
Yes, sir.
Utkarsh.
No
Yes. What do you
objection,
want to
sir.
say?
No objection, sir.
Okay. Okay. Just wait. I'm just connecting the PPT. PPT is visible, Utkarsh? PPT is visible?
Yes, sir. Yes, sir. Yes, sir.
Visible, na? Okay. So, little bit about what I have discussed last times. Uh, just a minute. So we have discussed last times these switches. Um Switches can be relational based devices or can be logic devices. Logic devices generally used for photonic packet switching. This one is called contention resolution by delay lines. These things it is used for packet switching, photonic packet switching. Other switches are generally used for circuit switching, what I have discussed. Next, we have discussed also the wavelength converters. Wavelength converters, it is the modern day communication systems. Um, it is not wavelength is not converted to one wavelength to another wavelength. Keep in mind here only information is converted from one wavelength to other wavelengths. Wavelengths are fixed, but informations will be rather you can say transferred from one wavelength to the other wavelengths. Right. This is called actually wavelength gating. Sorry, optical gating. These things are called optical gating wavelength converters. Right. And I told you this can be implemented using semiconductor optical amplifiers, semiconductor lasers, nonlinear optical loop mirrors. Those things are there. These are advanced components. Right. Semiconductor lasers, though we have discussed, nonlinear optical loop mirrors. Um, it is like a loop of fiber can act as a optical loop mirrors. Right. Anyway, those things are beyond your syllabus, but those things can be used for wavelength converter. And here I have shown these two techniques for wavelength converter. One is cross phase. One is based on cross phase modulations. And this is the most useful uh, wavelength converter. Of course, a limitation is here. Only one wavelength. It is one wavelength conversion is possible. If you consider WLAN systems or multi-wavelength systems, that times of course this method is not suitable. So cross-phase modulations can be implemented using either Mach-Zehnder interferometer or can be Michelson interferometer. I think the two comparisons, sometimes it might be asked, Michelson, then don't confuse this one. The first one is for Mach-Zehnder. I'm just showing pen. pen. So here you can see it here in Mach-Zehnder. I told you it is a closed loop interferometer. You see two Barson couplers are there, and it is closed, and two semiconductor optical amplifiers are placed asymmetrically to create the phase difference between these two arms. Right, and here you can see CW signal lambda C is here. From this side is launched, and other side lambda input signals at wavelength lambda s, which carries informations, is launched. And here, actually, our intention is to convert the informations from lambda s to lambda c. Right. So here, what happens actually when the semiconductor amplifiers will be modulated. I mean, the signal beam, when the signal beam will pass through these semiconductor optical amplifiers, the refractive index modulations will be there. Right. I mean, both gain and refractive index modulation would be there when the information carrying signal propagate through these semiconductor optical amplifiers. Right. Now, if CW continuous wave signal is launched from this side, or it can be, I told you, it can be co-directional, it can be counter-directional. Here it is, of course, counter-directionals. In this case, you see, when the CW signals will pass through this modulated both gain and refractive index semiconductor amplifiers, then informations it will carry the same informations as the input signals, right? I mean, in fact, this will happen because of the phase difference between these two arms, right? Uh, So asymmetric in the sense that here here power ratio, splitting ratio, it is generally 69 to 31 in this ratio. it is here, these two arms. Whenever the signal is propagated here, it will be in this ratio. That's why asymmetrics. So phase difference will be there. Because of this phase difference, the CW signals will carry the same informations as the input signals. But here, the same thing there for this Michelson interferometer also. Here here, it is not a closed loop. Here only one coupler is required here. You see, here two couplers are there. 2x2, one 2x2 coupler, another 2x2 coupler. This is 2x2 coupler, another 2x2 coupler. Right, two couplers. But instead of two couplers, here only one coupler is required here. Of course, there will be some reflecting mirrors will be required in this here. So here all the same things is here. Phase difference, everything will be there, but here reflection will be there. Here, how it is being used here, information collection is launched from this site and CW signal is launched from this site, and this after the modulation of these gain and respective modulations in the similar optical amplifiers, the CW signal when it passes through these devices, it will carry the same information as the incoming signals, input signals. Right. So in this way, you can have the wavelength conversions. But both these cases, limitation is there. It is only used for one wavelength conversions. And also here, rate, it is up to generally, it can handles 10 Gbps, 10 Gbps per second, 10 Gbps systems, right? Up to these things. Right. So for multi-wavelength or more high-bit systems, then you see you need some other techniques that is called 4-way mixings. It is actually FWM, 4-way mixing, different frequency DFG, different frequency generations. Right. Here actually what happens in this case, these two techniques that can handle multi-wavelength conversion. Also, a transparency to the modulation format also can be realized in this case. So main thing here, the advantage is it is multi-wavelength. Multi-wavelength conversion is possible. Conversion possible in this case. A little bit complicated here. I'm telling you here. In this case, actually, what happens for 4-way mixings, there will be interaction. Actually, 3 waves are interacting. There will be nonlinear materials easier. These nonlinear materials. It can be semiconductor optical amplifier also. In fact, you see there are 1, 2, 3. 3 waves will interact within these nonlinear materials. What happens? The 2 waves actually, when they interfere, they will form a grating, right? Out of these 3, they can form a gratings, right? And two input waves, they form a grating structure, grating. And third one, when third one, when it is scattered by this grating, it will generate a new wave. So that is a 4th waves. That's why it is called 4-way mixing, right? The 4th wave will contain the informations that is carried by any one of the 3 input waves. But other 2 must be constant. So any of the 3 waves, one wave will contain the informations, right? But other 2 will remain constants, right? Other 2 will remain constant. Other 2 is constant. Then the generated waves, which is the 4th waves, this is the generated waves. Generated wave, 4th wave, this will contain the informations that is carried by any one of the 3 input waves, provided other 2 waves are constant. So that is the principle of 4-way mixings. Right. Um, okay. Another technique is this here, different frequency generations. Here actually, it is based on pump wave and signal waves. This P means it is pump wave, and this is the signal waves. So interactions of these two will be there, and non-interactions of the will be there, and it will create another waves that will contain the informations of the signal waves. So it is based on this. I mean, difference of these two waves will be there. There will be two input waves. One is called pump wave, another is called signal wave. And after knowledge interaction within the materials, it will create and another wavelengths, right? That will contain the same information as the input signal waves, right? So with these configurations, and in fact, several wavelengths, there can be several input wavelengths, can be several output wavelengths, right? So multi-wavelength conversion is possible with these two techniques, right? So this is all about these wavelength conversions. This is the most important the component nowadays for the modern day optical communication systems. So anybody, if you have any questions regarding this, you can ask. Otherwise, I'll go to the next modules, optical networks. Anybody, if you have any questions, कोई किसी क्वेश्चन है तो पूछो, नहीं तो बोलो yes or no बोलो. कोई किसी क्वेश्चन है तो बोलो. शशांक, उत्कर्ष, कोई क्वेश्चन है तो बोलो, नहीं तो नेक्स्ट टॉपिक में जाएंगे. किसी का कोई क्वेश्चन है जो सुन रहे हो बोलो.
No, sir.
Okay. Next, you see, we'll see the networks, optical networks. I mean, here different type of networks are there, but we'll focus on these. I mean, here also the network can be, bus, maze, ring. Those things are there, right? Those things already have studied in the data communication systems, right? Here also you can have the bus network, ring network, star network, etc. But we'll focus on the ring networks at this moment, right? Of course, mesh network. So I mean, is there? I mean, modern systems now switching from SONET. Actually, SONET, most of the cases, existing networks are based on SONET rings, but sometimes for other facilities also, now people are now switching to the, I mean, vendors are switching from SONET rings to mesh reading, mesh or advanced type of RON. That's called RON. It's called SONET or SDAs. RON networks is there. Anyway, so what are the things that there in the syllabus? Let us first discuss it. If you have time, then we can discuss other things. So here you can see SONET or SDH rings. To some extent, we have started in your data communications. These are based on these. SONET means synchronous optical network, and SDH means synchronous digital hierarchy. Right. This is SONET. It is in US, and this SDH. It is other than US, like India. SDH terminology is used. These are actually based on digital time division multiplexings, right? Digital time division multiplexings. Digital time division multiplexings, right? These SONET are SDAs, right? And digital TDMs. So obviously some special frame format is here. So SONET frames. Let us see how we can calculate the SONET data rate, different levels of SONET or SDH that we should know. Next, we'll see how this SONET A SONET frame. First, we'll discuss SONET frames, frame format, SONET or HDS frame format. And next, we'll discuss the ring networks, ring and other networks. Right. There can be single hop network, can be multi hop network, etc. So first, we'll discuss the ring network. Before the ring networks, we will discuss the SONET frames. SONET is based on the digital time division multiplexing. So you can see it here. This is the SONET frame format. And you can calculate the transmission rate also. First, you see the SONET frame format. It's a 90 column format. You can see it here. It's a two-dimensional structure. There are 90 columns are there, and 9 rows of bytes are there. By means 8 bits, right? And here you can see the first 3 column contains the section. Actually, that is used to connect. I mean, these 3 connects adjacent equipments. And line here, line means it's a link that connects two SONET devices. That is the meaning of lines. And path, sometimes you see the path, line path. Path is a complete end-to-end connections. End-to-end connections, that is the path. So we'll see the function of these 3 columns also. It basically is for the network management. Yes, yeah, it is. What happens? What is not there? Anyway. So here you can see SONET, the period it is frame period, it has 125 microseconds, frame period, 125 microseconds. So you can calculate the transmission bit rate of SONET signals. And basic SONET signal, that is the STS1, SONET signals. STS means synchronous transport signals. There is the most basic one, STS1. Next, other one will be STS3, STS12, like these things. Right. Generally, STSN is used. Right. So STS1 transmission bit rate, that will be 90 columns. So 90 bytes per row will be there into 9 rows. I told you this is a 90 column format, 2-dimensional, 9 rows are there. So 90 bytes per row into 9 rows per frames into and 1 byte. Byte means it is 8 bits. So 8 bits per byte. So, and since it is the 125 microsecond, so it is divided by 125 microsecond per frames. So that will give you 51.84. Just to have seen this, we have seen it how T1 is calculated, T1 rate, digital subscriber lines, DS T1 rate, 51.84 Mbps. That is a basic SONET levels, which is STS. The basic one, it is called STS1. Right, and if it is STSN, that will be n times of these ones. So if it is STS3, then it will be 3 times of this one. Most probably it is STS3. You can see it here, 51.84. Next is 1 multiplied by 3. So that will give you 155.52. Right. So these are actually SONET levels. But I told you in India, it is not the STS1, it is HDH. So in that case, in HDH, these levels are termed as STM. The most basic one, STM1. STM1, that is equivalent to STS3. Say in BSNL cables or Reliance optical fiber cable, you can see there, it is not written STS. STM, synchronous transport modules, STM written there. The most basic one, it is 155, the STM1. Nowadays it is generally 10 Gbps. So it is STM64 like these things. 10 Gbps, STM64. You can see in the print, you can see in the cable it is printed there which STM it is. So in HDAs, these are the different levels, right? Okay. And when this STS or STMs, when it is used to modulate the source, so these are the electrical signals, STS. Now, when it is used to modulate the optical source, then it will be electrical to optical conversions. So that times the optical signal which is obtained after modulation, it is called OCN. OCN, OCN, optical carrier, right? And link, OCN links, right? So SONET links generally are referred as OCN after optical conversions. So OC1 corresponds to STS1, that is 51.84 Mbps. Like say OC92, that corresponds to STS92, that is around 10 Gbps. Right. So this is the different OC levels. They are equivalent SDH levels. And also here something you should know regarding this, the functions of different. Here you can see the function of the three columns. I mean, three columns are used for network management. If you see here, the first three columns, these three columns, it carries the network management information, these ones, right? And next 87 columns, 90 minus 87 columns, it is for synchronous payload envelope, right? That is for payload, right? Of course, one column consisting of 9 bytes, 9 rows are there, so 9 bytes will be there. One column or 9 bytes, that is used as path overhead, POH, path overhead, right? POH means path overhead. And that is actually used to support the performance monitoring. This is for performance monitoring. This is for performance monitoring. Performance monitoring. Monitoring of any equipments. The equipments will be there. The status, signal labeling, user channel, etc. So this is for the functions of POH, right? And this will be in this. It can be anywhere within this payload, right? It's not necessarily particular positions. It can be anywhere within this 87 columns, right? And if it is STS N, this is STS1. STS1. Right. If it is a STS3, then STS3, then it will be 3 times of this one. That times 270 columns will be there. Right, 270 columns. And that times, for STS N, it will be N times column will be there. N times wider will be there. STS3, so STS3 that corresponds to STM1. That I mentioned it is here. STS3 that corresponds to STM1. So column will be now, in that case, column will be 270. 270 columns will be there. Right. So this, in this way you can have it. And this actually the SONET or SDH, if you see the equipment from different manufacturers, then SONET or SDH specifications are there for optical sources, receiver sensitivity or distances for various types of fibers. Fibers are also specified for ITUT. Fiber can be, GI fibers can be, we have seen these things, can be dispersion shifted fibers, can be non-dispersion shifted fibers, like these things. So, so for interconnections, generally, the SONET or HD specifications should be there, and ITUT they specify the different types of fibers and also different wavelengths for different distances. Right. Say for 80 kilometers, generally it is 1550 window. I'm just one example. I mean, these things you can have it in Kaiser, new version of Kaiser, you can have it. That is white paperback, you can have it. Right. So for 80 kilometers, wavelength, generally it is used 1480 to 1580 nanometers for 80 kilometers. For 80 kilometers links, the wavelength window, it is 1550, but the range is 1480 to 1580 nanometers. Right. And also fiber attenuation is specified 0.3 dB per kilometer, like these things. And receiver sensitivity also is mentioned, like say for 80 kilometers, generally receiver sensitivity of the order of minus 34 dBms receiver sensitivity. Optical power also generally is mentioned. It depends upon the number of wavelengths. Per channels, generally it is around 8.0 dBms. And maximum power, generally it is plus 17 dBms. Power is expressed in terms of dBms with respect to 1 milliwatt. So for different distances, different wavelengths are there, different receiver sensitivities are there, and different wavelengths of sources are there, as well as different powers. They are being specified for the SONET or SDH. So these details you can these optical interfaces regarding fibers, types of sources, types of receivers, sensitivities, types of wavelengths. You can have it in the Kaiser details. The different tables are there. You can see it. Next, you see these SONET or SDH. Generally, these are actually used in SONET rings. SONET or SDH rings. You see, SONET or SDH rings. And this SONET or SDH rings, they actually called the self-healing rings. You see, self-healing rings. That is because if the traffic is disturbed, or some link failure is there, any node failure or ring failure is there, then the traffic can switch to a protection or alternate or standby path. If standby path automatically, right? If there is a link failure is there, link failure or node failure is there. That's why these rings are called SONET or SDH rings. They are called self-healing rings. And there are three main features of SONET rings are there. What are the three main features? The SONET rings can be 2 or 4 fibers between the nodes. 2 or 4 fibers can be there, right? That is number one. Number 3, the signals within the ring can travel clockwise. If it is clockwise, then it's called unidirectional path switch rings, UPSR. Unidirectional path switch ring, that is based on 2 fibers. but it can also be the signal can travels in both the direction, clockwise and anti-clockwise. That time it is called bidirectional, and that time it is called bidirectional line switch rings, BLSR. That can be also two, can be 2 fiber or the 4 fibers. But UPS are unidirectional ring that is based on 2 fibers, right? So it can be unidirectional or it can be bidirectionals. So signal can travels unidirectional or bidirectionals. But in the nodes, there can be 2 fibers. So based on this type of rings, the node to node, in between two nodes, there can be 2 fibers or 4 fibers, right? And also within the rings, you see there can be line switching or path switching schemes are implemented, right? Line switching and path switchings that are implemented within the rings. What is line switchings? In case of line switchings, if there is a link payload is here, then line switching scheme, it will move all the signal channels to a particular fiber, to a protection fiber. I mean, protection fiber, or you can say secondary fibers, right? All the signals can switch to a protection fiber. That is the line switchings. Okay. Line switching. That is the meaning of this line switchings. When the link failure is here, then the signals can be switched to a protection fiber. That is the line switchings. And what is the path switchings? In path switching, case of path switching, if there is a failure is here, then the individual payload channels, there can be sub channels. Let us say OC, if you consider say OC48, say OC48 is shown here, say OC48, the channels, it may consist of say two OC12 channels, 24, maybe some other OC3 channels. Those things are with it. It may consist of different sub channels. So maybe it may consist of four sub channels can be there. 4 sub channels. So in case of path switchings, whenever failure is here, right, then the payload can be transferred to a particular sub channel to another sub channels within this OC48. Right? So that is the path switching. So in case of path switching, signals may switch from one sub channel to another sub channels. Right. That is the path switching. And in case of line switching, whenever link failure is here, then the signals can switch to a protection fiber. So one is path switching, another is line switching. Keep in mind. So these things, both the things are implemented in these SONET or SDH rings. Right. The popular SONET rings that are used, you see examples are showing it here. It can be UPSR, unidirectional path switch rings, another is bidirectional line switch rings. These two are popular SONET rings. It's an example of unidirectional path switching rings. You see here, you see 4 nodes are connected to the primary fiber. It's a primary path. And the dotted line, this is actually the protection path. So in this case, if say node path 2 breaks or node 2 fails, just a minute. Harshvardhan, you have not joined today this class. Anyway, I'm just finishing this. I mean, I am asking the others, those who are present, Sasank and others, those who are present, I'm asking them to give the timing. Okay, after this. Okay, after this class, I'll discuss once again. You say 6 o'clock. Okay, right. 6 o'clock. And also, in Friday, extra class will be there, 10 to 11. And that time also you must mention the quiz 5 date, quiz 5. At least date you mention, timing can be decided later on for quiz 5. Okay. Okay, I'll check it. Okay. Okay. So, okay then. Uh, in UPSR, you see, if node path 2 breaks or node 2 fails, then you see the node 3, that times node 3 will switch to the protection channels to receive the signal. Suppose that times it's a node. If you see the node 3, initially actually the signals are launched both in the primary path and in the secondary protection path. So if primary path fails, then say node path 2 breaks or node 2 fails are there, then still node 3 will get the signals from the protection path from 5 to 6, 5 and 6, right? It will switch to the protection channels to get the signals from node 1s, right? So that is the UPSR, UPSR. And in case of this is an example of bidirectional line switch rings. In this case, you can see it here. There are also 4 nodes are there, but it is 4 fibers are there. You can see it are 4 fibers. These two fibers, these are for primary 2 fiber path, and these are secondary fibers. These 2 fibers, these are actually secondary fibers. Secondary fibers, you can see it here. Primary fibers for normal bidirectional communication. You see it here. Say node 1 to node 3, if you just consider, then node 3 can receive signals from 1P to P, and node 1 can receive signals also return path through this 7P and 8P, 7P and 8P. You can see it here. So it's a bidirectional rings, right? 2 secondary fiber loops are there for protection purposes. These protection purposes. Okay. And all the characteristics of this BLSR is you can see it here. Here, one half is completely independent of the other. One half, if you see one half, it is completely independent of the other because of these bidirectional cases, right? So it will have capacity advantage compared to the UPSR. Right. Now suppose you see if certain node fails, any card fails in node 3, a card failure is here in node 3 or node 4, any card failure is here, then the protection segment protection segment means these ones, secondary fibers. The protection segment between 3 and 4 will be the part of the primary bidirectional loops. So other links will remain unaffected, right? So it is more versatile compared to the previous ones, and also I told you it is completely independent of the other because of these bidirectional cases. It is completely in the previous case you have seen the whole loop is used, but here only half is sufficient. So because of these things, capacity advantage is then it is more versatile compared to the path switch rings, right? And you can see different cases, like say if complete failure is there. Here it is showing if complete link failure is here, enter node fails. Right. Then in that case, you see card failure is here or total link failure is there. You can see link failure is here. Then the nodes, say node 3 and say here node 3 and node 2. If this link failure is here, complete link failure is here, then also traffic will resume. That is because of these things. The internally they switched. Internally switch the primary path protections from their receivers and transmitters to the protection fibers. You see it here. You see this is. You can see it here. Internally they will be connected. Internally they will be connected. In the node 2 and node 3, the complete link failure is there. So either side of the link failures, if the link failure is a particular link, then the primary you see primary path connections will be switched to the protection fibers. You can see it here. They will internally switch the primary path connections. One is primary path connections, another is protection path connections, right? So the primary path connections can be connected to the protection path connections, right? To get the traffic back to the previous node. So again, it will form the closed rings. But these times, if such a condition appears, I mean here, then all the primary and protection fibers will be used around the entire links. All the links will be used in that case, in the typical conditions. So this is actually the different cases for BLSR. BLSR. Anyway, so today up to this one, what I'm saying, say there are line switch rings, it can be path switch rings. Path switch ring here, you see, it is not so versatile because only it is based on 2 fibers. And here, if there is a node failure is here, then the connections can be switched to the protection path. And in case of bidirectional BLSR, you see, if complete link failure is here, in between, then internally switch for any node on both sides of that the span, both sides, say node 3 and node 2, the receiver and transmitter, they will be internally connected, right? In both sides. So again, they will form closed rings. But these times connected to the protection to the primary path to be connected to the protection path. Protection. I mean secondary fibers. Primary fibers will be connected to the secondary fibers. So in that case, you see, all the links will be in used. Both the cases. Right. This is the complete link failure case. Here it is one example it is shown in here. If a particular you see this is primary path connection failure is here, then also you can see it here. It can be switched to the protection path, not for a protection path. This is secondary fibers. This is secondary fibers. This is a primary fiber. This is a secondary fibers. These things are there. So anyway, these are the different cases. More details you can have it in the Kaiser that white paper back. That edition it is, which edition it is? Third editions. Third edition. That you must see it. Third editions. And it's a book. The network you'll get it in the third edition book only. This type of things. So anybody? Yes. Yes. Anybody is saying some things? I'm stopping this one. If you have any questions, you can ask. And also, yeah, anybody saying anything? Anyone? No. Sasank, so the timing is just now. So the mention about timing. It is 7. What?
6 p.m. I think, sir.
Huh?
6 p.m. on that Friday.
6 p.m. Just let's check it whether WhatsApp video whether it mentioned or not. 6 or 7. 6.
Since sir, we have another quiz 7 from 7:15, sir. So
Anyway, he has not mentioned. So he agreed that
yes, sir.
it will be on 6 p.m. Na?
Yes, sir.
Others, those who are listening, it's okay. What Sasank is mentioning, 6 p.m. It's okay. Say yes or no. Sahil, Rohan, Bisal.
Yes, sir. It's okay.
It's okay, na? 6 p.m. So I'm just noting it because I have to convey these things. 6 p.m. Okay. 6 p.m. on 8th. 6 p.m. on 8th April. Six p.m. Okay, 6 p.m. April, and Friday extra class will be there, right? Friday 10 to 11, apart from the regular class 12 to 1, and you see that times you must mention about the date for 5th quiz. Okay.
Yes, sir. Yes, sir.
Okay.
Yes.
Quiz 5 date you must discuss yourself and tell me about the 5th quiz date. Not next week, next to next week, last week. Last week, what time? Because immediately you have to mention it, because otherwise you will be again burdened with the other quizzes. That's why you decide yourselves. So Friday you must Friday 10 a.m. that time you must mention about your on the final quiz. Okay, then if you don't have any questions, then I'm stopping. If you have any questions, otherwise I'll stop it. Anybody, if any questions, say yes or no.
No, sir.
Okay then.